This is part 7 of the Craftsman Emerson Gen 4 Commercial Drill Press Rebuild series. If you haven't seen part 6, click the link at the top of the screen. In this video, we're going to be comparing some of the internal parts between a standard Gen 4 and the commercial model Gen 4. We will also be doing some final cleaning on some of the parts in preparation for assembly. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. In comparing commercial and standard Gen 4 models, we're going to first look at the feed stop bracket. You can see that the commercial model is more robust and it's made out of cast iron as opposed to cast Zanuck. And the feed stop rods are actually exactly the same. Same thread, same length. Here we have the two spindles, the top being a standard model. And its size is a 5/8 inch diameter by 17 inches long, where the commercial model is 3/4 of an inch in diameter and 16 3/4 of an inch long. So on the commercial model, the two areas where the bearings sit are 17 millimeters, where on the standard model, it uses a 5/8 special bore bearing. So talking about those bearings, you can see that the outside circumference is much larger on the commercial models, and that's because the quill is larger as well. And the bottom bearing for the spindle quill for the commercial model is a double row ball bearing. And we have to remove the thrust collar to get that bearing off of the spindle. There's a link in the description of the video that is a spreadsheet that has all of these measurements for you already. So these are the two quills. And the one closest to the camera is the commercial model. You can see that it is a much larger quill. They're the same length, and they both have the exact same gear rack on them, but their bore diameter inside and outside is different, and the commercial model is actually thicker as well. So looking at the commercial model, there is a nut that goes in the bottom that holds that bearing in place. The snap ring is different. It's a two-part snap ring as opposed to the single snap ring that goes on a regular or standard model. Standard model also has a washer, and the quill gaskets are different as well. The standard model is smaller because of the smaller quill, and it's thinner. These are the two pinions, and you can see the standard model is shorter, but otherwise they're the same diameter. So they both use the same fiber washer because their diameters are the same. The commercial model uses a roll pin to retain the spring, where the standard model uses a standard drift pin. And the springs are different as well. The commercial model spring is longer. It's about 6 1/4 inches. There's a plastic cap that goes on the hub, and then you've got the eccentric bearing. And the pinion rides inside that eccentric bearing. Now, it's interesting to look at the eccentric bearing. This is why it's called that, because one side of it is thicker than the other, so the hole in the center of the bore is offset. And that allows you to adjust the distance between the pinion and the quill to take up any backlash. The hubs are different as well. The hub on the commercial model is got a hole all the way through it, whereas there is a stop on the standard model. So that pinion only goes in so far, whereas the pinion in the commercial model goes all the way through the hub and protrudes from the other side. That's what the black plastic cap is for, to cover that after you've installed the spring. That roll pin just goes in there, and that's what captures one end of the spring. So the spindle pulley assemblies are actually exactly the same. They use the same bearings. The inserts are the same length, and they're the same diameter. The splines on both of the spindles are the same, so these parts are all exactly the same. But I wanted to point them out here because some people think that they use different bearings, and they don't. These bearings are the exact same on all of the Gen 3s and Gen 4s. Here we're looking at the head casting, and you'll note on the right the commercial model has that split head, and it utilizes those 3 set screws there that actually adjust that gap in the head. If we look at the bottom of the head, you can see that the split continues, and that the bores for the quills are a different size because the quill is larger for the commercial model. Looking at the left side, you can see the hole where you insert the machine screw that holds the spindle pulley assembly in the head. There's only one on one side. On the back, they're basically the same. And if we look at the right side, the biggest difference is going to be the bore for the pinion, because we have that eccentric bearing that goes inside that bore. Otherwise, the head castings are relatively the same again. So if we look down inside a head casting, you can see that roll pin that's in there. And that's what captures the spring on the inside of the head casting. And the commercial model head casting has the same roll pin and looks very similar to the standard model. And that should cover most of the internal parts and their differences between the two models. So we are back on cleaning up parts, and here I'm just wire wheeling parts that we've already simple greened and derusted with citric acid. So we're just knocking off anything else on them and cleaning them up with the wire wheel. So pretty much every single part gets wire wheeled that is metal. And this is like a 3-hour process to finish off the remaining bolts and screws and that kind of stuff. That looks like one of the split ring for the Jacob's chuck, and that's one of the jaws for the Jacob's chuck. The jaws on this Jacob's chuck were in really good shape, so I didn't have to hone them or anything. So after we've done all of that, we can move on to cleaning out any of the bores in any of those parts with a wire brush. We're just getting the WD-40 out of them that we had put in there to keep them from rusting. After we've wire wheeled all the holes in all of these parts, then we will be coating them with that super slick stuff. It's a penetrating oil. And you can get it at Ace Hardware. I don't know if any of the big box stores carry it, but I love it. It's great stuff. It's got kind of a citrusy smell. So the belt cover was in dire need of a cleanup, so I'm going to spray it down with some simple green and then use a Scotch-Brite pad to clean it up. After that, we'll rinse it off and set it aside to dry. So this is the panel that goes on the hub, and this is the back side of it. And it's applied to the hub with some double stick tape. This is that 3M double stick tape. So I'm fairly certain that's what they were using. And it will just all peel off as one piece once you get it started. Like so, and then we'll clean it up with some acetone. Before that, I'm just going to use a little dead blow mallet and knock out any of the bends or dents we may have put in it when we removed it. And then we're cleaning it up with the acetone. We're not going to submerge that because we didn't want to remove any of the decal lettering on the other side of it. But we'll clean up that side with this Meguiar's Cleaner Wax. This is what I use to clean all the panels with. And there's the scale. So basically I just apply this and then set it aside and let it sit for about 15 to 20 minutes. And then come back and buff it off with a rag. But we'll just apply this to all these panels. Obviously, unlike a 100 or 150 series, we have a lot of panels on the Gen 3s, 4s, and the commercial models. That's the face panel for the belt cover. Now, originally, all these panels came with like a clear piece of plastic over them that you're supposed to peel off, but a lot of people don't. And over the years, I've had some drill presses where I could just peel the plastic right off of them, and then some where the plastic was just adhered onto it like acid tape, and you couldn't remove it. You can see the switch panel that's towards the bottom of the screen there, and it's kind of yellow, and that's that clear plastic that's on it. And it's on there really good. I end up trying to remove it from that panel, and you'll see in a minute how that turned out. So this side panel did not have the clear plastic on it. The other side panel does. So it's really adhered on there, and I'm using an X-Acto knife to try to scrape it off of there and still preserve the lettering that's on there. And that does not go as hot as I wanted it to. So this is the other side panel that has the clear plastic still on it, and it's not coming off either. It's very adhered to the panel. So we're just going to clean up that panel And then we're going to buff all of these panels to get the cleaner wax off of them. They all clean up really nice except for the switch panel and that one side panel. So for that side panel that has the plastic still on it, we're just going to buff it off, and then we're going to apply a clear coat over it. And that'll keep that from peeling in any way. And for the switch panel, we're going to go ahead and strip it completely. And I've already got a decal that I printed out in vinyl sitting just slightly above it there. That after I finished sanding this thing, I dry sanded it with 220, and then I wet sanded it with 320 all the way up to 1000 grit. Then we cleaned it off, and then we cleaned it with some acetone. And then we're ready to apply the decal. And then after we've applied this decal, we're going to clear coat it as well. Peel off the transfer film, and yeah, looks pretty good. So here I'm just using some Dupy Coat clear coat, and I'm going to spray down both of these panels. And then once they're dry, they'll be ready to rock. Next thing we're going to do is we're going to apply some of this Scotch 3M double-sided clear tape to the back side of the hub panel. This stuff is pretty thin. It's probably about a 1/16 of an inch thick, maybe a little thinner than that. And once we've got the whole backside covered, then we're going to go ahead and cut it out, trim it, so that none of the tape protrudes outside of the panel. We'll use an X-Acto knife for the inside hole. Then we can peel that double-sided backing off of the tape and then apply it to the hub. There's no right or wrong orientation here. I just like lining it up the way I did. And the big thing is to make sure that the center hole is really well aligned with the bore, so that when we push the pinion through, it doesn't snag on it. And there you go. Next, we're just going to clean up a bunch of the electrical components with this electrical parts cleaner that I use. You can get it at Home Depot. They probably have it at Lowe's as well, but the switches, the wiring, all of it I'll clean up with this stuff. And the last thing we're going to be doing is cleaning up the belt cover. So it's had time to dry off, and we're just applying the Meguiar's cleaner wax to it. And we're going to buff this in all the way around the exterior of this thing. And then we'll let it sit for about 20 minutes. And then we'll use a rag to buff it off of there. We'll come back with some Q-tips and clean out some of those little holes that the previous owner had drilled all over this belt cover. And the automotive paint that I use on the drill press, I don't think I can use it on plastic, so that's why I didn't paint it. I've never painted one of the belt covers. But that'll wrap up this video. I hope you found it enjoyable. If you did, please like and subscribe. In part 8, we'll begin assembly. So I appreciate all the support, and I will see you next time.